So this is a short video on surface machining. Here I am going to design a small smiley and then making it doing its machining in surface machining workbench. So first going to the part design. Here I am going to design the smiley, which I am the actual smiley, which is going to be a machine part after machining a rough stock. So first selecting the preferred plane, so I am selecting this XY plane and then making a circle. So choosing a circle from this profiles, different profiles are here in this workbench. Then making it constraint, so making is 200. Okay, then making it constraint. You have to make constraints because no design is complete without constraints. And then exiting the workbench, then making it 20 mm, it's correct, and then choosing the upper plane. And now we are going to make the eyes of this smiley. So making again constraint, this one should be 40, and then again making it constraint, should be 40, and this should also be 40, making it 40 again. And now using a mirror operation, this operation is called mirror. This uses a sketch which we want to mirror. This is the axis, so it's got mirrored and already constrained. So exiting the workbench, and then using this pocketing function and then giving it 10 mm. Okay, then selecting the plane inside this pocket and then making the eyeball of this smiley, then projecting this part. It will be projected in the lower plane, you can see this. Now making the eyes of the smiley, let's set it to 15 mm and then making it constraint again. So and then deleting this projecting part, this is not of use, and then making it mirror about this axis, this y axis, when it is already constrained. So using this extrude function, reverse direction, reverses the direction of extrude, and then setting it to 12 mm. Now its eyes are made, so selecting this plane and then making its nose. Here we can use a centered rectangle for which you can make the nose of this smiley. So here we choose it 45 and this dimension is 16. Again we have to position it by giving it proper constraints. So here we get 8 mm and then here 22.5 mm. So here it is properly constrained. So exiting the workbench, then giving it extrude function, then setting it to 10 mm, and then here we get this smiley face, nose, and then giving it smile. So we can go to again sketch, giving a point. Here we can position the point. This should be 50, 45, and then the other one should be selecting this dimension part, and then this should be again 40. Okay, now this point is positioned. So using the mirror command, here we can mirror this point, and now we can use a 3-point arc. This 3-point arc starting with limits, because we have to set first the limits, and now we can change the radius. So here then making it constraint, again, and then making it constrained. So here we got the mouth of the smiley, and now we can pocket it to the end. So 20, setting 20, okay, we get the pocket. Now we have completed the face, but we have to dress up this all smiley face. So now selecting this fillet, selecting the edges which we want to fillet. We need 7 mm preview. Now we get it's looking like an eyeball. Now setting this, again fillet 7 mm. Okay. Now selecting one more operation because this is not looking like a nose. That's why giving it a nose like structure. So here we have to select the two faces between which we want a circular fillet. So we have to select a face which you want to remove. Now on preview you can see it is removed. So now it is removed. So selecting this and again giving it a fillet to make it a cute nose of a smiley. So preview, and now we get this. Now setting for machining we want a safety plane also. So making a safety plane. So here we can select a plane. Here we can position the plane from here. It is 30 mm, and now when we make a rough stock, so rough stock should be 10 mm above 40, and then making a 2 mm clearance, so 42. So this will be a safety plane. Now after for machining we want fixtures also, but fixtures we have to make fixtures on the rough stock. This is the finished part. This will be the finished part. So first we can make rough stock here also, and in the machining workbench also. So in the machining workbench it is better to make from machining workbench because it is customized and it reduces the machine time. So that's why we are using a machining. We are going to machining workbench, then surface machining. So here we have reached in surface machining workbench. Here we can use different type of geometry management to give the rough stock to the part body. So here selecting the part body, and now selecting this part body in which we want this stock by offset. We have selected the offset 10 mm, then preview. Here we get the desired rough stock, which is machined, and then we get the desired part body. So okay, now here we want some fixtures also. So again going to this part body. Now we have to select the fixtures. We have to make the fixtures, sorry. Then insert one new body, and then we have to make fixtures. So we can make fixtures from here. Fixtures can be of any dimension, so we are not concerned about fixtures because fixtures are designed differently. So we are using a body like fixture. So here we have to constrain it again. So here constrain the sides and then the position. In the design everything should be constrained. So here only one fixture is not sufficient, so similar fixtures are needed. So we can use a rotate feature. Now we can rotate it. We need 3 instances for this. Okay, now all these should be constrained. So using a auto constraint option. This auto constraint is used to constrain the all the sketches automatically using stack, and then okay, these all are constrained. So exiting the workbench. So here we can give this extrude of 15 mm to this. So here we got the fixtures and all things, and we are ready to machine. It's like in the actual machining we are ready, all setup is maintained and we are ready for operations. So here we have to first give the parameters for the operations. So we have to set the type of machine. We are using 3-axis machine, then this reference machine axis. So this reference machine axis is okay with our machining. This is at the center, this one. We can change this axis from this, and now we have to define which part we want to machine. So part 1 is correct, and then this part body, the machined, that will be a machine part. This rough stock, that is going to be the rough stock, which it can be called a blank, which we are going to give in the machine. And now the fixtures and the safety plane. The safety plane is here, and then all are selected, then clicking OK. Now we have to select the operations which we want to do. So first selecting roughing operation. So this roughing operation is going to open. So here we have to set different parameters like rough stock. Rough stock, we have selected this one is the rough stock, and now the part body is this one, and this check is the fixtures. So we have to hide this to define in the checks. So here we have defined the checks, which are the fixtures. The safety plane is here in the part body. This one is the safety plane, and now we have to check. We have to give the offset for how much the roughing operation is going to machine. So this offset is on the fixture. So we have to set is 10 mm, because the rough stock is 10 mm at offset from this part body. So selecting offset of 10 mm. Now we have to select different parameters how it's going to machine. So it's machining mode by area, and its outer part and pocket. So outer part and pocket is okay. Then we are going to use helical tool path style. Then machining tolerance is 0.1 mm, it's okay. Then climbing cutting mode is climbing, which is a conventional mode, which is we are going to use in machining. And then helical mode, and then radial overlap tool. Then we have to set this step over length. Step over length is decided after we have to set, before we have to set this tool dimension. So for this roughing operation we have to set. So for roughing operation we don't want a ball and tool, so we are selecting a zero radius end tool. So here we have to select this dimension. So this diameter of this tool is 8 mm. Now we have selected this 8 mm diameter, so we can select this step over. Step over is always 60%. So we are, for good machining, we are selecting is 4 mm. Then maximum cut of depth. We are setting it to we have 8 mm, so we have maximum cut of depth to 3 mm. So after selecting all the parameters, we can set all these parameters also, but we are not actually machining this is a only a practice video. So then executing this, it will generate a path for this tool movement. So you can see here a path is going to generate. This is a tool path. So here we can see this green one is the cutting portion, where in which the tool will be in will cut the metal, and this red part is air cut. It is the time in which the tool will not cut, so it is the waste time. So we have to reduce this time. So we have to do machining properly, we have to choose path properly to reduce this machining time. This we can see here 45 minutes is taken by this roughing operation. So again for other operations we have to do. So after selecting this roughing operation, we can select other operations. So the next operation will be Z level. So here we can see here different operations are there. So selecting Z level, this one is Z level. So here Z level should be second one. So here we have selected the Z level. So here then selecting here, no rough stock is needed because it is a finishing operation. So we have to select the part body, then check is these. So hide this one and selecting the checks. After that we have to select a safety plane. So in the part body we have the safety plane, and now these are the different parameters which we have to set. First we have to give the machine part offset 0 because this is a finishing operation, and then offset on check should be 10 mm because these are the fixtures, and then these all parameters which are default we are going to set is which are okay. Then pass overlap we have to set, and offset on tool path, all these parameters we have to set, but before that we have to change this tool. This tool should be 8 mm, so it's okay. Now we can use for you can use this for Z level. So then setting the parameters, other parameters, pass overlap should be 3 mm, then offset on tool path should be 4 mm, and zone maximum horizontal shape, these all are output we can set. The distance between passes we can set to 1 mm, step over should be constant, and now we can generate the path. First we have to part auto limit gives the limits for automatically set the limits. So we have to uncheck this. Now we can generate the path. Now the path is generated. We can see that it is machining only the vertical faces, and that's the original means of this Z level. So it's complete, and this red part is air cut, and the this green part is machining. So now selecting the other operation, which is also a finishing operation, this sweeping. This operation is used for finishing all these profiles like this one. It gives a very minute cuts, and it is used for like we have to make surfaces, like we have wavy surface or surface, any surface we can machine, we give a finishing cut from this surface. So selecting the part body, now selecting the checks, so hiding this, then check, selecting check. These are the fixtures. This offset is 0 also, and offset on check is 10 mm. Now selecting this machining tolerance, we have to select for better finish. Maximum distance between passes 1, and then scale of height, step over side, all axial maximum levels, selecting 2 levels, maximum depth of cap 1 mm. So setting all the parameters and then changing the tools. This tool we have to change. So now selecting other tool. So we are going to use a radial tool, ball and tool. So cancel this, use a ball and tool, and then selecting this 6 mm. Okay. Now we are ready to execute this file. So all this safety plane is not set, so we have to select the safety plane. So all these parameters are set. Now we can execute to generate the machining path. So here we can see here the shipping operation tool path is generated. This red is denoting the similar, the air cut, and this green one is machine cut. So here this 1 hour and 7 minutes is taken by this operation. So here the whole things are generated, you can see. So to preview this machine operation, we can use these operations, this command. See, in shipping we can go to this tool path replay, and then this video from last saved result. So here in on going to this video part, we can see how this machine is going to happen, and we can change the machining paths so that no accident happen during machining. So we can see here we can fast forward this machining time using this. So here you can see how machining is going. So this is a roughing operation, that's why. And now this sweeping operation is done. So here you can see how this finish is accurate and good. This is first level. So second level is left. You can see here these fixtures are left as it is. Now this fixtures part, this useless part can be removed in second setup. This is only the first setup to maintain this, the upper plane, upper face. You can see this operation, how correctly finished is this. We can reduce the step over length and the size of tool to get a better finish. Now this is the finished part. So now for generating this similar part in a machine, we can generate a NC code and then give it in the machine, and the similar smiley face we can get in our real life. So first we have to set which software we are going to use for NC coding. So here in tools we can go in machining, and then in output here the post processor and controller emulator folder. We have to select out of these three. These are the three softwares which are in collaboration, which are compatible with catiaV. So selecting this Senit R, and then going to this, in this one you can see NC output management. Here we can go to generate NC code in batch mode. So before doing this, we have to save all these processes. So because this needs an input which is saved, so saving this, save, desktop, smiley, save, yes. Okay, now this smiley is already made. Now this is saved also. Now this you can see previously it was blank and it is already filled now. Now we can select this NC data type. So we are using NC code, and now we can decide the location where we want to store this. So this is in temporary files. So selecting it in desktop, selecting OK. Now this execute part is not highlighted because we have not defined that which post processor file, CentiV post processor file we are going to use. We have decided CentiV, you will see in the options. So we can use different, these are controllers, so we can use controller depending upon the machine. So now we can execute this. Okay, on executing. So here this all these NC codes are generated here, you can see. So these NC codes are, you can see the NC codes are written in NC data, this cat NC code. So opening this in notepad, you can see here different coordinates are there. These are only the coordinates according to which the machine gets the coordinates and cuts the face. So here we get this all smiley. This is a new methods which are used in the industries to generate various models automatically using machines, NC codes and catiaV. So thank you.